In this video, we're going to look at graphing linear equations and also working with those equations. And even though this is kind of a review topic for a pre-calculus class, it's a really important set of skills to have mastered as you go on to calculus. So we're going to make that one of our standards. All right, so first of all, when we talk about a linear function, what are we talking about? Well, we're talking about a function that can be written in this form, mx plus b, where m is a number that we call our slope, and then b is the y value that the graph has when it crosses the y-intercept. So we would say 0 comma b is the y-intercept. Or sometimes you'll hear me refer to it as the vertical intercept. All right, so let's look more specifically at slope here for a second. So what is that? It's the set of instructions for how to get from one point to another, and what it tells you is the change in the y value divided by the change in the x value. Okay, so, or another way of saying it is rise over run. So the way we practically do that, if we know 2 points that our graph is going between, then we take the difference in the y values divided by the corresponding difference in x values. So here's an example where we will graph two linear functions on the same set of axes. So first of all, let's graph this function f here in blue. And so we can see that we're multiplying x by 2/3, so that is our slope. And then remember, what is the slope? It's the change in y divided by the change in x. Change in y divided by the change in x. Okay. So again, that's the set of instructions for how to get from one point to another. But we have to have an initial point that we know is on the graph. And one way we can do that is to look at our y-intercept value here, right? So anytime this number here that I'm adding or subtracting from the x term is an integer, then we might as well start off with that as our first point. So we know that 0, -1 is the y-intercept. So that means we go right here to 0, -1, and that's our starting point. And then I look at this 2/3 as my slope, and that tells me that if I go +2 in the y direction, I would go +3 in the x direction. +2 in the y, +3 in the x. And I can also go back the other way. I can go -2 in the y as long as I also go -3 in the x. And the reason for that is because if I take a -2 change in y and divide it by a -2 change in x, or -3, excuse me, change in x, then that's going to give me +2/3. So when you see a positive slope, it really just means that the change in y and the change in x have to have the same sign. All right, and then we can go ahead and sketch this, and I'm just going to kind of use sort of a dashed line here. Not that you should do this necessarily, but the reason I'm doing it is because I find it much easier when graphing on the computer here to keep things straight if I kind of use little dashes instead of a solid line. All right, so let's take a look at the other one. We'll graph this one in red. So we see that the slope is -2. Now, let's understand that the other one was really nice because it was already a fraction. So I could identify 2 as my change in y and 3 as my change in x. But keep in mind, we can always force an integer to be a fraction by just putting a 1 on bottom. So this is -2/1 as our slope. And I can also see that 0, 3 is the y-intercept. All right, so we'll start at 0, 3. All right, so -2/1. The negative just means the y and the x have to have opposite signs, or the change in y and change in x have to have opposite signs. So if I go -2 in the y, that's fine as long as I go +1 in the x. negative 2 in the y, positive 1 in the x. But then I could go positive 2 in the y, negative 1 in the x, and so on. All right, and so with that, I can make my red line here. So we have both of these graphed. And then lastly, what I'd just like to say is that you can double check that your slope is correct, in that if I have a positive slope, as I move left to right, I should be going uphill like I am in the blue graph. And as I go from left to right, if it's a negative slope, I should be going downhill as I am in the red graph. Now in this example, we're going to take a look at coming up with the equation for a function where we're given 2 points that linear function goes through. And then we're also going to graph the line. So we've got the point 1, 3, and I can go ahead and put 1, 3 on the graph here. And I've got the point 5, negative 2. Puts me right there. All right, and so what we have to do is we have to come up with what the equation of our function looks like. So f of x is equal to mx plus b. All right, so m being our slope, right, that's the change in y over the change in x, but remember we introduced the idea that you can just take two y values, take their difference, and divide it by the corresponding x values, and that is your slope. So if I pick negative 2 to be my y2, and I pick 3 to be my y1, then I would divide it by the corresponding x value. So negative 2 went first on top, so I'm going to put 5 first on bottom, and then minus off the 1. So you should always have the y and x that go with each other kind of lined up vertically here. So that gives me negative 5/4 as my slope. So to kind of update where we're at here, we now know that f of x is negative 5/4 x plus b. So we got to figure out what b is to complete this equation. So there's a couple ways we can do this. One way is to realize that these points are on our line. So what that means is that if you stuck them into this formula here, they would have to work. So if I plug 3 in for my f of x, right, because remember f of x is just a y value, right? So if I plug 3 in for the y value, and I plug 1 in for x, then that gives me a little equation I can solve to figure out b. Now I could have put in 5 and negative 2 just the same, and we'd come up with the same answer. But here we just have 3 equals negative 5/4. And you know, in anticipation of the idea that I need to get this 5/4 to the other side, I know I'm going to need common denominators. So let's make this 3 over 1 into a fraction first. And of course I need it to have a 4 on bottom in order to be able to combine these. So just in anticipation of that, I'll go ahead and do the work to make my common denominator. So this becomes 12 over 4. Okay. Minus 5/4 plus b. So then I'm going to add 5/4 to both sides. And so that gives me 17/4 as my b value. Okay. So now I know what b is, right? And I can give my answer of f of x is equal to negative 5/4 x plus 17/4. Okay. I do want to just quickly show another way you can do this. There is what's known as the point slope formula that many of you may remember. And what it says is if you take y minus a particular y value, that's going to be equal to the slope times x minus a particular x value that goes with this y value. So I can pick one of my points up here. So I'll pick y minus 3. So I'm picking my point 1, 3 is equal to negative 5/4 x minus 1. And you can see here we've got y minus 3. We distribute our negative 5/4 through. negative 5/4 x plus 5/4. But then this should look pretty familiar, right? In the sense that I've got 3 and I've got 5/4, so I've got to add them together, right? So this is really, from our work over here, is really y minus 12/4 is equal to negative 5/4 x, plus 5/4. And then if I add 12/4 to both sides, we're out of space, but we get 17/4 over here, and so we just end up with this exact same answer that we got here. All right, and then lastly, you know, since this is a line, let's go ahead and do our best to sketch the line going between these 2 points. Okay. And I suppose we know that the y-intercept is 17/4, which would be 4.25, so it should cross right about here, which it looks like I'm doing. All right, and so there's a picture of our line. All right, now in this example, what we're doing is we are given the equation of a line, but it's not in that nice slope-intercept form. All right, so when we encounter one of these, there's a couple of ways that we could do it. One of the ways is to force it to turn into slope-intercept form. Okay, so we could do that. Another way is to find the intercepts, the x and y intercepts of this particular equation, and use that to graph it. Okay, so we're just going to run through both of those real quick. Okay, so on the one hand, if we put in slope-intercept form, we know that slope-intercept form is where we have f of x equals mx plus b. So in other words, the f of x or the y should be by itself. So this technique just centers on solving for y. So I subtract 4x from both sides. Negative 3y is equal to 12 minus 4x. And then if I divide both sides by negative 3, then I get y is equal to negative 4 plus 4/3 x. So just dividing both terms by 3. And we of course realize it doesn't matter the order you write it in. The fact that I'm multiplying x by 4/3 means that's my slope, and I know that my y-intercept is 0, negative 4. Okay, so that's my slope-intercept form of my equation. Okay. On the other hand, I could just simply find the x and y intercepts. Okay. For one thing, I know that all I need to accurately graph a line is 2 points. But it's particularly important to graph accurately on the x and y axes. And so by finding the x and y intercepts, we'll guarantee that we do that. So we can just find our x-intercept, okay? And we know that when we have an x-intercept, if it's crossing the x-axis, that means the y is 0. So I'm literally just setting y equal to 0 and finding x. So that's 4x equals 12. And so divide by 4 gives me 3. So that means that 3, 0 is the x-intercept. So that means that I could put a point right there. And then similarly the y-intercept, we already know the answer. We know it's 0, negative 4. But without getting it in slope-intercept form, we can figure that out by just setting the x equal to 0, right? Because on the y-axis, x is 0, and solving for y. So negative 3y equals 12, divide by negative 3. and y equals -4. So that puts me right here. And you can see that if I took this equation and I plotted 0, -4, and then I followed the slope instructions, which are to go up 4 over 3, I'd get that exact same thing. Now, because I do know that the slope is 4/3, for good measure, I'm just going to go ahead and do another point here. So that makes it a little bit easier to graph accurately. All right, so now we're going to take a look at a couple of really simple looking equations. So this one is x equals -2. So the thing to notice about this is when you have x equals -2, there's no y involved. And so when you see that, the way to interpret it is to say that x is -2 no matter what y is. So it doesn't matter what y value we're talking about, x is always -2. So when y is 0, x is -2. When y is 4, x is -2. When y is -7, x is -2. So we quite literally here just end up with a vertical line that goes through all different y values, but where x is always -2. So anytime you see an equation that looks like this, x equals a number, that is always going to be a vertical line. All right, and we've seen this one earlier in the class, but we'll review it again here. F of x equals 3. Let's remember that f of x is a y value, right? So we really have y equals 3. So what does that mean? There's no x, so it means no matter what x is, y is 3. So when x is equal to 0, y is 3. When x is equal to 7, y is 3. When x is equal to -3, y is 3. And so for every single x value, y has to be 3. And so anytime you see f of x equals a number, you know that that's going to be a horizontal line. All right, so now we're going to look at the concept of when lines are parallel. Okay, so we say that two lines are parallel if their slopes are equal, or if in the case of vertical lines, we know that there is no slope because it's undefined, and so if you have two lines that are both vertical, they could be parallel. That's kind of the exception. All right, so in example 6, it says write the equation of the line that is parallel to f of x equals -3x plus 1 and passes through the point 2, -1. Okay, so let's first understand that because parallel lines have the same slopes, we can say that our line has a slope of -3 also. Okay, so as I start to write the equation for our line, g of x equals -3x plus b. Okay, but since we know it goes through this point, we can figure out what b is by plugging the x and y values into our equation. So we get -1 equals -6 plus b. So that means that b must be 5. So our equation is g of x is equal to -3x plus 5. So I go up here, y-intercept of 5. Remember, -3 really means -3 over 1. So that means down 3 over 1, down 3 over 1, down 3 over 1. And so we can get a sketch of our g of x function. But then we were also asked to graph the original one, so in a different color here, let's grab a grab a red pen to graph f. So f has a y-intercept of 0, 1, but it also has a slope of 3. So if I go down 3 over 1, down 3 over 1, or if I go up 3, left 1, up 3, left 1, and I graph this red line, what I should hopefully see are basically two parallel lines, two parallel lines that won't intersect. And sorry, my graphing skills on this red line were pretty bad, but you get the picture here. These two lines are parallel because they are never going to intersect with one another, and that happens precisely because their slopes are the same, because from any 2 points they go the same in the y direction and x direction to get to the next point, so there's no way they could ever cross paths. All right, and the other concept we want to talk about are perpendicular lines. So it says that lines are perpendicular if the product of their slopes is -1. Okay, and then what that means geometrically for us is that they intersect at a 90-degree angle. So what that means is if one line has a slope of a divided by b, then in order for their product to be -1, you would have to have the other one's slope be -b over a, so that if you multiplied these, you get -1. Okay. So example 7 here says, write the equation of the line that is perpendicular to y equals 3/2 x minus 2 and passes through the point -5, 3. So the first thing we'll notice is that our line has a slope of -2/3. Why? Because if this one has a slope of 3/2, I flip the fraction and take the opposite sign. Okay, we call these opposite reciprocals of each other. Opposite for different sign, reciprocal means flip. Okay, so our line is looking like this: y equals -2/3 x plus b. I'm not sure what that is. We'll go ahead and plug in a 3 for the y and a -5 for the x. And so we've got 3 equals 10/3 plus b. And as we've had to do before, we realize that we're going to have to subtract these numbers. So I'm going to make my 3 into a fraction. And I'll realize that my common denominator is 3. So this will end up being 9/3 on the left. And then I know that I'm going to take 10/3 away from it. So 9/3 equals 10/3 plus b. Kind of run out of space here, sorry. So that means that this is -1/3 is my b. So my answer here is y equals -2/3 x minus 1/3. Now what we've often done is used the y-intercept as our starting point, but notice that it's not a nice starting point. We want one that gives us integer values. So that's okay. Just go ahead and use the point they gave us as our starting point. So we don't have to start with the y-intercept. So we can go -5, 3 as our first point, and then follow the instructions here, right? Down to right 3, down to right 3, in order to get a nice picture of our line. Okay. And then let's graph the other one just to confirm that we are making that 90-degree angle with our two lines. So we'll do this one in blue. So 0, -2 is our y-intercept, and we're going up 3 over 2, up 3 over 2. I can go down 3 back 2. Okay. And besides my wobbly lines here, I think it's pretty believable that we're making a 90-degree angle between these two lines. All right, the very last example here, I want to take a look at one where they give us the equation that we want to be perpendicular to in not a slope-intercept form. So it says, write the equation of the line containing this point and perpendicular to this line. So we first need to know what is the slope of this line here. And the quickest way to do that is to go ahead and get it in slope-intercept form. In other words, get y all by itself. So we get y is equal to 3x minus 5. Okay. So, and we can go ahead and graph this here. So we know that this really is 3 over 1, right? So we have a y-intercept of 0, negative 5, and we're going to go up 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1. So there's a picture of our original line here. Okay, but what we're trying to do is make a line perpendicular to it. But we can do that now that we've realized that the slope is 3. And so anytime you have a whole number here, automatically make it 3 over 1. And then that'll allow you to realize, oh, okay, my line has a slope. And we'll go ahead and state it here. Our line has a slope. Oops, sorry about that. Let me erase that. Our line has a slope of the opposite reciprocal of 3, which is 3 over 1, so it's negative 1/3. So y equals negative 1/3 x plus b. And so again, we can use what we know here. We've got a y value of 2 on our line. Got an x value of negative 1. So this will be 2 equals 1/3 plus b. And again, I'm going to need this to become a fraction with a common denominator of 3. Okay. Switching colors here. So we'll go, and let's go over here because I'm kind of running out of space. So this will be 6 over 3 equals 1/3 b, 1/3 plus b. So subtract 1/3, and we get that b must be 5/3. So our line is y equals negative 1/3 x plus 5/3. So like in our last example, we see here that what we want to do is not start with the y-intercept as our first point. Let's start with negative 1, 2. So we'll start right there and then use the slope here, down 1 over 3, down 1 over 3, down 1. Well, I can't quite get another point on there, so we'll go up 1, back 3, up 1, back 3, and then just do our best to sketch our line in there. All right, and it certainly looks like we have two perpendicular lines.